Now today we are going to have a look at geomorphology. Now I would just like to share with you the following, that geomorphology is very, very important for your second question paper. You know how many mistakes creep in the second question paper simply because you are not on par with your the content of the geomorphology syllabus. So what I'm going to do this afternoon is that lots of the explanations that I'm going to do, I'm going to refer you to map work as well. Now, we've got a map work session later on this year. I think that's in the third quarter. But it's very, very important that you see the relationship between fact and map work, content and map work, especially when you're busy with geomorphology. In fact, with any other part of the work as well. But we know many students have problems seeing these facts when it comes to geomorphology. So when I'm busy explaining things to you, don't only listen to the explanations, but try to get to see how I apply the different geomorphological facts on maps, on diagrams, and so forth. We will also have a look at last year's question paper of the geomorphology questions that have been set, as well as the February-March paper that has just been written a few days ago. So, okay, without further ado, let's have a look at our geomorphology. Now, obviously, we won't be able to do everything, but what we are going to discuss here will be stream patterns, stream order, longitudinal and cross profiles, fluvial landforms, stream piracy, and rejuvenation. So these are the things you'll see that most of the parts of the syllabus we are touching on in our discussion this afternoon. Now, okay, as I've said, we are going to kick off with stream patterns. So let us have a look at our different stream patterns. Now, Matric, last year there was a very important question with regard to stream patterns, which I will share with you later on. We had a few problems with those who answered those questions regarding stream patterns. So please take note when we are busy with stream patterns. Okay, now, when we have a look at stream patterns, people, the most important stream patterns, firstly, the dendritic one. Now, I would just like to put on all of them, and then we will actually see where we should be. I want to start off actually with this one here. You must know the following with regard to stream patterns. Please, Matric, when you prepare yourself, you must know this. You must study your stream patterns in this manner. The first thing is that you must know what everyone looks like. Okay? Secondly, you must be in a position to give a description of each stream pattern, and then, very important, you must know the underlying structures below the surface of the earth that have caused this structure. Now, many of the matrics have problems with this last one. Okay, so stay with me and see if we can solve a few things with you with regard to stream patterns. Firstly, people, the dendritic one. Dendritic, it looks like a tree. In fact, it comes from the Greek word dendron, that means tree. Now, when you have a look at the dendritic one, you must know that the underlying structures would be uniform rocks. Uniform meaning the same. Okay. Then the trellis one. The trellis, we've got alternating layers of hard and soft rocks. Let's have a look at this one. Here we've got the trellis one. Now, what we've got is, then you'll see we have parallel streams. Look at the streams here that we've got all roughly parallel to each other, and the streams will flow there. We have the soft rocks, and here we'll have the hard rocks, then with soft rocks, hard rocks, and soft rocks. And you know that of course the streams will be able to erode the soft rocks much quicker, and for that reason they flow where you have your soft rocks, and that's the reason why we have these parallel streams. Then the radial from the highest point. Radial, it actually looks like a bicycle wheel, and it actually flows from the highest point in different directions. The word rectangular means 90 degrees. Okay, but remember, people, when you come to the rectangular one, there are two things with regard to 90 degrees that you must remember. At the rectangular pattern, let's look at this one. Can you see the bends are 90 degrees? I'm coming back to this again. Look at that, 90 degrees. But what's also important is the tributaries. Look at them. They are joining also at 90 degrees. So please remember, rectangular, two things with regard to 90 degrees. I must remember the bends are 90 degrees, as well as the tributaries that are also 90 degrees. Now, where do we find them? We find them where we've got lots of joints and faults in the underlying structures. Now, when you study your stream patterns, as I've told you, it's very important that you must be able to recognize them on your topographic map. And as I've said in my introduction, I'm going to lean very heavily on topographic maps and as well as orthophoto maps or satellite photos like this one in this case. Now, have a look at this. Remember, what did we say about the dendritic? Looks like a tree. Have a look at that, okay? So this will have our uniform rocks here. This is the trellis. Remember, you must the previous slide, you must bear that in mind all the time. What did we say about the trellis? Alternating hard and soft rocks. Have a look at this. There we've got brown, parallel brown, another parallel brown, and another parallel brown. And look at the rivers. The rivers are also flowing parallel between these mountains that we've got here. Look at the tributaries, very short, and sometimes they join also by 90 degrees. Please, people, don't confuse the trellis with a rectangular pattern. We often find that in exams that people confuse the trellis with a rectangular. Remember the trellis, that the tributaries, they are very short and they flow down from a very steep slope sometimes, where the result is that they join the mainstream also by means of 90 degrees. So please don't get mixed up with the trellis and the rectangular. Okay, right. Let's have a look at the rectangular. Remember, what did we say with regard to the rectangular? We said the first thing we must remember, the bends 90 degrees. Have a look at this. Lovely bends. Right, and what did we say? What must the rocks? There must be cracks in the rocks. Have a look at this. Okay, nice rocks, and what's happening here is that the rivers, they are flowing actually here in the joints and the cracks. Look at this. The tributary. Here's a tributary coming, and it's also joining it by means of 90 degrees. So remember the rectangular. The radial one. Here we've got the radial one. Okay, the tebus, and here we've got a conical hill, and here we're seeing that all the rivers are actually flowing away from a central high point, which is here about 1,500 meters. Now, these are your stream patterns. Now, there are other stream patterns as well. Those are your four main ones. You've also got your centripetal, your D-range, and your parallel. When you study stream drainage patterns or stream patterns matrix, I would suggest that you make yourself a table like this on one page, right? And see if you can study it like this, because you've got it on one page, all the facts. Have a look at this. There are your different patterns, right? Here are the diagrams of each of them. Here's a description of each of them. Here are the underlying structures. So this is very, very important that you must study from a table like this. It's going to make your life much easier. It will compare the stuff for you, and you will be able to see the comparisons and the differences between all the different drainage patterns. Okay, now last year in the November 2015 exams, the following question appeared. You were confronted with a diagram, the drainage patterns and the landscapes that you've got here. Now, what's very important is that this was a simple question of matching, right? To match the drainage patterns with the landscapes. And I'm just quickly going to run through a few of these questions and just as a revision as what I've said with the different drainage patterns. Now, the first question there was, indicate whether each drainage pattern A, B, C refers to the landscape 1, 2, or 3. Which one is likely to develop? Now, I see a few, one or two schools here with us. I'm not going to give the answer now. See which one would you you must actually just see if A fits by B, or A with 1, B with 2, and for instance like that. Okay, so you must just indicate which one. So if you can just send me the answer, which one matches, which letter matches with which number, then at the end of these questions I will have a look at that. The second question here is, name one factor that results in the different drainage patterns forming. Now remember, when we started off with the drainage patterns, we told you that the underlying rock structure, am I right? The geology of the area, tectonic forces is another one. All these things determine the drainage patterns that you find, the differences in them actually. State one characteristic of the drainage pattern at B. Here we've got B, right? And the most important characteristic is that it radiates outwards. I'm still waiting for the answers. Those of you who can, please match the letters with the numbers. See if we can get to the right answers. Then number 4. Describe the rock type and underlying structures associated with the drainage pattern C. Here we've got the drainage pattern C, and of course, if you have a look at the drainage pattern C, it will of course join with this one. I actually didn't want to tell you that because that one's the answers I'm waiting for. It would be igneous rocks with cracks or faults in it, well-jointed rocks. That would be the answer there. Now the last one that they asked here is why do the tributaries in landscape 3 join the stream at 90 degrees angle? And if you can remember, we told you that these are very short tributaries that flow straight down the steep slopes. Okay, I see there's a few of you who sent in my answers here. One says 1 with B and 2 with C and 3 with A. Then I've got one here, A 3, B with 1 and C with 2, and A with 3, B with 1 and C with 2. Okay, so let's have a look and see, and you can check on your answers after I've given to you. I see most of you have about the correct answers that we've got here. So let us just match and check on if you've got your answers correctly there. Okay, so those would be the answers. Okay, the volcanic dome, of course, this would be, go with B. Okay, the jointed landscape would go with the rectangular, and of course A would be with 3. So I see most of you actually gave me the correct answer there. So at least you know how to match your drainage patterns. Now all you have to do is that you must go study, and this is very important, the underlying structures that have caused these drainage patterns. Very, very important. Okay, don't see that if there are any problems with regard to this. Okay, so now I'm going to have a look at drainage density, and there was a question of drainage density somewhere in the exams as well. Now have a look at this. Here we've got a high density, and here we've got a low density. And immediately the question is, but what's going on here? Why so many rivers in here, and why so just a few rivers on this side? Let's just have a look. Okay, now we have a high density drainage pattern when there's a high rainfall. There are hard rocks, where there are steep slopes, less vegetation, and less infiltration. That is where we have a high density. And the low density, people just have a look at that. If you know one of the two, you will know the other one as well, because the one is just the opposite of the other one. Have a look at this again. Here we've got a high density, of course, a high rainfall, right? Here, of course, because of the amount of streams here, we've got a lower rainfall. Now, hard rocks and softer rocks, this you must understand, people. Please, you've got to stay with me now. Why have we got so many streams here? It's because the rocks beneath, under the streams here, are very hard. Well, the result is that no infiltration can take place. And now most of the streams you will get on the surface of the earth. Look at this one. Softer rocks here. What's going to happen now? The water is going to seep into the earth, and what's going to happen here is that here you have much less streams than this one in the first case. Okay, now have a look at this one. Here we've got steep slopes, and here we've got gentle slopes. Now what must you understand here? When you've got gentle slope, then the river flows slower, and if when the river flows slower, then it means there's much more chances for infiltration. Okay, now then less vegetation here, lots of vegetation here. If you've got lots of vegetation, it slows down the flow, the tempo of the stream. Well, the result is that you've got much less streams. Now, Matric, what I've mentioned now here already was the velocity of the speed at which rivers flow. Now, did you know that if you know the speed of the river, where it's flowing fast, where it's flowing slow, people, if you know that, I bet you will understand about 70-80% of everything of rivers. Okay, you'll see as we proceed, everything has to do with the speed or the velocity that the water flows. Okay, so I'm going to mention that a lot during the course of this afternoon. Okay, now yeah, I've got a question. What do you mean by infiltration? Now, infiltration is if you have say a bucket of water and you throw it in the sand or whatever, and you've got loose sand. What's going to happen? That water will seep through the sand and go right into the surface of the earth. Am I right? But if you've got a rock and you throw the water on the rock, then the water is going to flow away because it's a harder surface. So your infiltration is when your water penetrates the surface of the earth or goes through the surface, and actually it accumulates under the ground. Okay, in groundwater, we'll talk about that also later on. Okay, so this is the drainage density. Now, here we go. This was the question that popped up in the November 2015 question, and it was a shorter question. And please, please, people, remember that to understand drainage density NB, you must understand the factors influencing infiltration. I see a few people here have mentioned again infiltration. You see people, at least 2-3 of you have done that. If you understand infiltration, then you will understand drainage density, right? Because there's a definite huge link between those two. Right, let's proceed. Now, what they did was they gave a few statements here, and all you had to do was to say if it refers to drainage diagram A or diagram B. Right. Now, let's have, of course, diagram A, which be the much higher density of the two. Now you must keep in mind all these things that I've explained to you in the previous slide were the factors that influence in infiltration. Now, let's have a look at this. Here we've got the first one. Dense vegetation cover that prevents surface runoff. Okay, so we've got here B. Okay, drainage basin that experiences a high rainfall. Very easy. Just can see this one is a much higher rainfall than that. Agree with me. Okay, more rivers. Drainage basin that has mainly clay soils. Now, here we've got drainage basin, clay soils. Now, what happens is if you've got a clay soil, then the water can't penetrate, can't infiltrate the surface. So what happens is most of the water remains on top. We call that runoff on top of the earth's surface. That is why we've got much more streams here. Okay, drainage basin that has permeable rock. Look at B. Permeable means that the rocks allow the water to infiltrate. So this is what we've got there. So it would be B. A river that flows through hilly areas immediately. If you see such a lot of rivers, all the rivers must start obviously at a higher point. So this means that here would be much hills here. Then drainage basin that has porous rock with sandy soils. In other words, again here, you've got porous rock. Porous means that the water can go through sandy soils. The water can go through, it can infiltrate through the sand. A river that flows through gently sloping land. Remember what we said there? That would also be your letter B here. Now, Matrix, can you see now the relationship between the previous slide and this one that I've just done here? And this was an exam question of last year. Most of the candidates who got this wrong did not understand these factors influencing infiltration. So make sure that you know all these things. Okay, let's proceed. Now, I want to carry on with something called stream orders. Now, stream orders, people, the basis of stream orders, you must know two very, very important things. You must know the concept of source, and you must know the concept of confluence. Right, now what is a source? Source is of course up here, the starting point right in the mountains where the rivers originate. Now, the confluence, have a look at this, the confluence is where one river flows into another river. Okay, that is called a confluence. Now, if you do stream orders, Matrix, the easiest way to understand it, and you can get sometimes messy on your hand, but I promise you will understand it much easier. Now, the stream orders can be very easily described if you look at your fingers. Now, if I should draw a few rivers here on my finger, yeah, I've got one coming down here. another one coming down there, and this one is joining up here. Here we've got another river coming down here, one coming down here, that's joining there, and then eventually these two join here, and here coming from my thumb, another one joining here. So here I've got 1, 2, 3, 4, 5 rivers running here on my fingers, and of course, there where we've got our source, right up here, my fingertips would be the source. So this would be my first order streams. So I'm putting a number 1 there, first order streams. So as I said, it will get a bit messy, but you understand it much easier. So those will be my first order streams. Okay, now have a look at this. Where you've got the first order stream joining up with the second, this is a confluence here, am I right? So where the first and the second and the two first join up, here we will get a second order stream. You got that? Here we've got another first order joining there at the confluence, a second order stream, right? Now see what's happening here. Now we've got a second order stream coming down here, another second order stream coming down here, 2 and a 2, that will give me a 3. Okay, this is a first order stream joining up again with a 3. What happens now? The highest order must go through there, so this would be if you look at your hand, you will have a third order stream on your hand. Okay, now bear this in mind when we are busy with our stream orders now. Okay, now let's have a look at this. Now, the first thing, as I said, here we've got our rivers. Now, as you see, I'm doing it on a topographic map because these things are also asked on your topographic map. So let's have a look, and please stay with me now because this is very important. What did I say? When you have a look at your source, there, all of them will have a stream order of 1. Okay? First stream order. Okay. Now, what did we say? When you've got 2 stream orders here at the confluence, look at there, a 1 and a 1. Here's another 1 and a 1, all right? So what's happening there, remember what I did on my hand, there we are going to get our second order streams, right? There we've got a 2, and so forth. Okay, what happens now? Where we've got the second order stream flowing into joining up with another second order stream, this is going to happen, okay? So we've got a third order stream there, all right? So what's happening now? Third order stream. If I've got 2 third order streams, this means the Groothoek River here is at that point here, it is a 4th order stream. So this is very, very important, people, that you must be in a position to work out what the stream order of a certain river is. Very popular question. And have I said, if you don't understand it, go back to your hand and mess a little around with your hand and study the things also by means of your hand, and you'll see how easy the stream orders really can become. Okay, now, what is very important is this. Here we've got what they're actually calling geography mathematics, not mathematics, because you will see that, remember, these are not sums. First, 1 plus 1 gives you 2. Okay, a first stream order plus another one gives a 2. A 2 plus a 2 gives a 3. But a 3 plus a 1 gives a 3. Because remember, the highest value, that's the one that it carries. 3 plus a 2, it will carry the 3. It's a higher value. A 3 plus a 3. Now, when I've got 2 3s, it becomes a 4. Have you got that? Then a 4 plus a 1, a 4, 4 plus a 2, plus 4, 4 plus a 3, then 4 plus a 4 becomes a 5, and so forth, and so forth, and so forth. Okay? So remember this table that I've given to you, and it's quite easy to remember like that. So these are our stream orders. Okay. Now, I'm going to have a look at the discharge of a river now. We are going to have a look at laminar and turbulent flow. Now, okay, what's very important is that you must remember what it looks like. Now, if you just by looking at these 2 rivers, you immediately see here's a huge difference between the 2. Sorry, here the waterfalls flow as parallel sheets. Here the water flows turbulent. Sorry. Here you'll see the river bed is even. That is why the river flows in parallel sheets. Here the river bed at the bottom is uneven. And because it's uneven, you will get this turbulent flow of water all the time. Now, if you have a look at these 2, of course you'll see that you'll have more erosion here. Look, you can just see at the speed of the river. See the way that the turbulent flow of it, and look at this, the slow parallel flow of the water here. less erosion. And of course, this type of flow you get in your upper course, and the other one, the laminar flow, you get in your lower course. People, this is quite easy, the laminar flow and the turbulent flow of rivers. Again, draw your table like that and see if you can study it this way. It's much easier to remember laminar flow and turbulent flow that way. Okay. Now, people, we are starting with what perhaps is I wouldn't say the most important, but it carries a lot of marks in the exam. Longitudinal and cross profiles. I can't remember an examination where longitudinal and cross profiles were not asked in the exam. So please, people, this part, longitudinal cross profiles, you must know everything here. Now have a look at this. Firstly, you must know what's the difference between the two. You must know that a longitudinal profile is a side view of the river drawn from here, right there where it starts from the source right down till eventually when it reaches its mouth there at the sea. That would be your longitudinal profile. Okay, the cross profile, on the other hand, is a profile drawn from the one side of the river, the bank, to the other one, right? So that would be your longitudinal and your cross profiles. Very important that you must be able to give a definition. And please, people, let me just cut off here for a second or two. We have a huge problem in our exams. When we have a look at the examination and we must compile a report of the exams and we sit with the scripts, then there's one very important thing that emerges, namely that candidates do not know their concepts. Okay, you must be able to define a cross-section, you must be able to cross-profile, you must be able to define longitudinal profile, all the other concepts as well. The reason therefore is that they can ask you define whatever concept, but the most important one is that they will ask a question and the concept will appear in the question. And then you can lose 6 marks, 4 to 6 marks. You won't be in a position to answer a paragraph type question because you don't understand. No, you don't know the question. I won't even say understand because you don't know the concept. So please, people, see that you are in a position to define and to apply all the concepts that you've got from your climatology right through your settlement, right through till the economy of South Africa. Okay, so let's have a look at the longitudinal and cross profile. Now, what's important here, people, is that you must know there's 3 stages of the rivers when it comes to longitudinal profile. Here we go. The upper course, the middle course, and the lower course. Now, people, can you remember what I told you in the beginning? I said if you know what the speed is of the river, then you know quite a lot of the river. Because then you actually can apply the fact of the speed of the river to most of the other sections of the rivers as well. Just have a look at this. The upper course. It's steep there. Just see what's happening now. Fast flowing. Because it's fast flowing, downward erosion. And that is why we've got waterfalls, rapids, interlocking spurs. Can you see that, people? Why? Why could you give that? Because you know that the water was flowing very fast there. Have a look at this. So this would be my cross profile. We should draw a cross profile here in the upper course. This is what it would look like. In the middle course, look at this. It's going to be very, very, very gradual there. Now, if you see that it's gradual, then what's going to happen now? This means that the water is going to flow much slower. Now, if the water flows slower, it's too slow to have downward erosion. So you've got erosion sideways or lateral erosion. And because you've got sideways lateral erosion, you will have your meanders and your spurs as well. That is what our middle course cross-section looks like. Can you see wider sideways erosion? Can you see this one? Compare this cross-section with the width of that one. And immediately you will see here downward erosion is the most dominant process. And here your lateral or your sideways erosion. That was your most dominant process that we've got here. Now, here's the lower course. Let's have a look at the lower course. It's almost flat. Now, have a look here. Steep, gradual, and almost flat. Immediately, you must just look at, remember, I'm repeating this all the time, just that you can understand what role speed plays here. Have a look at this. Steep, fast flowing, gradual, slower flow, almost flat. Have a look at this now. flows very slowly. Now what's happening here? Here with the process that we've got here is deposition. Why deposition? Because the water flows so slowly, it can't carry the weight of whatever the stream load anymore. And what happens? It deposits it there. Therefore we get oxbow lakes, deltas, meanders, marshes, braided streams, sandbanks we get there. And just have a look at our cross profile, even much wider than in your middle course. So can you see how easy this becomes, people, if you understand the velocity of the speed of the river, what the speed is in a certain part of the river. Very easy to understand it then. Now, just to make this a bit more clear, let's have a look at this video clip with regard to the longitudinal profile of a river.
Of a river comprises of three distinct parts. First is the upper or the mountain course where the river originates. Here, the velocity of the water is faster due to the steep gradient. The floor of the valley is narrow and the valleys are V-shaped. Second is the middle or the valley course where floors are wider and the sides of the valley are more gently sloping. Here, the velocity of the river is slower than the upper stage. Meanders are typical landforms found in this stage of the river. The third part of the river is the lower course, which has a gentle slope and is almost flat. The river channel is usually at its widest and deepest here, because the amount of water flowing within the river is at its greatest.
Okay. As you've seen in this video clip, it's actually a summary of what I've just tried to explain to you. Now, if we have a look at this summary that I'm going to show you now, then you will see exactly the same that we've found in the video clip. Now, a question came through here. Can you explain what a transverse profile is? Now, Matric, remember that the transverse profile is a cross profile. It's exactly the same thing. Okay? Transverse profile. What's a profile? It's from your one riverbank to the other one. Okay? So it's exactly the same, your cross or your transverse profile. Okay, let's have a look at the summary. Now, what we've got here, this is your summary of your longitudinal and your cross profiles. And this summary, you've also, if you study it this way, Matrix, I'm telling you, much easier to remember. Now, what must you know with regard to longitudinal and cross profiles? You must know what the cross profile, what it looks like. You must know the features and the processes that we find in your longitudinal profile as well as the landforms. And let's have a look at this. This is what the upper course, middle course and lower course cross profile or transverse profiles look like. Have a look at this, right? Can you see it gets wider the further you move down, much broader the further you move down your course. Now, have a look at that steep, gradual, almost flat. Okay? Now, have a look at this that we've got here. Of course, you can see here's it steep, here's it gradual, and there it's almost flat. Now, of course, if this is the case, here it's going to flow fast, here it's going to flow slower, and here it's going to flow very slow. Can you see how these things fit together now? And because it flows fast here, you're going to have downward erosion. If it's a bit slower here, you're going to have lateral or sideways erosion. And because it's so slow here that it can't carry the stream load anymore, everything, your sand or whatever, alluvium, is being deposited here. So your landforms will be your waterfalls, rapids and spurs. Here we'll get meanders and spurs in the middle course, and the lower course, sandbanks, marshes, braided streams, and oxbow lakes. So what you must know now, people, is that how do I identify these courses on my topographic map? Very easy. Of course, your dominant color here is brown, so it's in the mountain. So it's steep, fast flowing. You see all these things are being repeated here, so easy. Okay, so this will be your upper course, or as is also known, your young river. Why young river? Because it's flowing very fast. You guys are very, very young still, so you can run much faster than your teachers and of me, of course. So that's the young river. Then we've got the middle course, right? As it exits the mountain, here's the river. Have a look at that. Of course, look at that. Gradual, slower flow, right? Meanders, spurs, or whatever that you get there, right? And that's what we call the mature river. And then eventually the lower course or the old river, yeah, it's flowing so slow. Deposition. How do I know here's deposition? Look at all the sandbanks here. All right? Look at the marshes here. Okay? So the sandbanks here show you lots of depositions. What do I get here? The mouth, of course, at the sea. That is your most important fact that this is in the lower course. Then the marshes I've mentioned. We've got our floodplains here. Here we've got our meanders that we've got here. We've got a braided stream. All these things form because we've got a broad floodplain and because the river flows slowly. And of course, in very big capital letters here, that the whole area is level. In fact, if I must look here, I don't even see one contour here. So this is very, very, very flat, the lower course. Okay, I just want to move on to something called river grading. Now, what's very important is that you must be able to distinguish between an ungraded and a graded profile. Now, this is very easy, all right? An ungraded profile, there you will find a waterfall and you will find a lake. These are your temporary basis of erosion. So it's you'll even find the rapid dams and all these things. This is an ungraded profile. Have you got that? Okay. Now look at the graded profile. A graded is a smooth profile. Have you got that? Look at this lovely smooth and convex profile. In other words, all the temporary bases of erosion, this means the waterfall, the lake and all these things have been removed. What's going to happen? This waterfall is going to disappear one day. It's going to be eroded away. Your lake, because of deposition, is going to be filled up and your lake won't even be there anymore. Okay, so that would be your graded and your ungraded profile. Usually I do this cross profile around a bend when I come to floodplains and meanders, but I'm doing it now because it was included. This is the way that it was examined in one of the question papers. So let's have a look at the cross profile. Remember, we were busy with our cross profiles, we were busy with our transverse profile, and very, very important people can see. Just look at this photo here. The first thing you must notice here, faster flow, slower flow. Have a look at this photo, beautiful photo. First thing that you notice, look at the amount of stones and gravel on this side of the river. And look at that of the river. Now, what does that tell you? That tells you that the river flows very fast on that side, and on this side, the river is flowing much slower because deposition is taking place here. Okay, so this is, what does my cross profile around the river bend look like? There we've got erosion, right? And on this side, we've got deposition. The photo says it all. You can see where all this material has been deposited. Okay, that side is called the undercut, and this one is called the cut-off slope. Please, people, you must remember this. Now, have a look at this. If we want to draw a cross profile from X to Y, now, Matrix, now you must stay with me. Because remember, all the cross profiles that we've looked in the previous slides was where the river was running straight. Have you got that? We had it in the upper course where it looked like that, the middle course like that, and in the lower course it was completely that. But now we've got a problem that now the river is doing that. Okay, meandering. So what is the profile going to look like? And if the river meanders, this is going to happen. The one side the river is going to flow faster and the other one side is going to flow slower. But Trix, can you see I'm emphasizing that again, the velocity or the tempo at which the rivers flow. If you know that, you can do lots of work, you understand lots of work of your rivers. Okay, let's have a look. So, if I must draw now my cross profile from X to Y, this is going to happen. Have a look at this. You see the build-up of sediment here because of the deposition. Have a look at this. Right, here we're going to have deposition. And here we're going to have a steep slope in the river here. Have a look at that. Because we've got erosion, can you see the fastest current? In other words, the speed is very fast here. Look at the slower current, the slower speed of the river on this side, meaning deposition on that side and meaning your erosion on that side. Take note where I put X and where I put the A. People, that must be like that in the exams if they ask you to draw such a cross profile. Please don't turn them around. Then your profile is 100% correct, wrong, okay? Completely wrong. You must have the X and the Y on exactly the same place, okay? So please take note about that. So this is what your cross profile will look around the bend. Right, this was the question in the exams in November. that had to do with profile and drainage basins. Name one source of the river drainage basin A. Here we've got it. That would be rain, snow, springs, quite easy. What term best describes B? Here we've got our drainage basin and we've got that. See, where's B? So that's right on the top there. So that would be the source. What is the stream order at point C? Have a look at this. Here's C. There's a 1 and a 1. Can you see what the examiner did? They left out the 2 there. They wanted you to go and put the 2 in there. Okay? So that gives you the 2 there. And another 1 and a 1, that also gives you a 2. This means that 2 joins up with that 2. So that 2 and a 2 gives you a third order. So that would be a third order stream. Quite easy. All right. What would be found at D here? See this at the C. So that would be a delta. The process that gave rise to the alluvium or the deposition here at E, of course, it would be deposition. Okay. The term describing the water movement at F. Can you see what's happening here? Infiltration. Somebody asked that question earlier on. See, the water is infiltrating or going down right through the Earth's surface here. Right. High-lying area surrounding the drainage basin. Here we've got the high-lying area, and of course that's called a watershed. Matric, your concepts, please don't forget that. The lowest point to which a river erodes would be the permanent or ultimate base of erosion. Now this was the way that they set the questions in November 2015. Now in the February exams, this is the way they set it, and this was actually an easier question. They only asked short questions of this section. And the first thing that you had to notice was what is the course between A and C. Of course that would be the upper course. What is that area called? That would be the C. The source, sorry. Here by B, what type of erosion would we have here? Downward erosion, right? 3, what landform have we got here? A waterfall. Can you see, it's easy questions. What slope do we find? Now, that is one. They can remember why I did that now. Okay, this would be the slip off of that. That would be the undercut. Remember, the river is flowing in that direction, so it's going to be much, much, much faster there. And then, is this a graded or ungraded profile? Of course, it's an ungraded profile. Why? Because there is a waterfall. Okay, so please, people, can you see how all these different parts of the geomorphology has been brought together to set that exam question there? Okay. Let's have a look at fluvial landforms. Now, fluvial landforms are just the oxbow lake. You know, it's a floodplain. Here's your floodplain. Now, what is a floodplain? They love to ask this question. It's found in the lower course of a river. It's flat, and they are adjacent or just next to the river. So this is the floodplain that we find here. Here's the meander. There's my delta. There's a braided stream. And these are the fluvial landforms. So let's have a look at a few of these fluvial landforms. The first one would be a waterfall. Now in the previous slide, we have spoken about the waterfall. Now what's very important, they can ask you, you know, how our waterfall is formed. What are your keywords there? Your keywords at your waterfall is you must have 2 types of rock. You must have hard rock and soft rock. Hard rock and soft rock. So let's have a look at this. Here you've got your harder rock and here you've got your softer rock. Now what's going to happen is erosion is going to take much quicker place here, and because it's going to be eroded faster here, this means that the water will actually do this. Okay, and you're going to have a steep slope here, very steep slope here, and the water is going to actually fall over that slope. Okay, then remember your keywords: softer and hard rock. That's your keyword. Rapids, actually the same. In fact, some people call rapids small waterfalls, and I think they're not far wrong if they call it that. Now, what's happened also flows over harder and softer rock, but the height is not so. The height difference is not that big, and what happens is as it flows over it, you get this turbulent flow of the river at your rapids. Okay, oxbow lakes. Matric, this is a very popular question that they ask you how oxbow lakes are formed. So let's have a look at the formation of oxbow lakes. Now, what's important, people, is that you must know these steps, these 4 steps that I've got here. The first thing that you must remember, and this is very, very important, that the oxbow lake is formed where you get a meander. And that's very, very, very important that you've got that. Here you've got a meander that you've got here. Now, see what happens now. As this comes down this side, remember we said you must know where the river flows fast and where the river flows slowly. Now what happens? On this side, you're going to get on erosion, on that side deposition. That side erosion, that side deposition. So what's going to happen? This is going to erode away, and see what's happening in step 2. Because of erosion there and there, the meander neck becomes narrower. Have a look at that. And then what happens is, then we've got that this meander, this neck, it actually breaks through here. The neck cutoff begins to occur, and then, have a look at this. This neck, this meander is completely cut off, and then the river flows straight, and here where the meander was, we actually get an oxbow lake. Now, I would just like to show you how oxbow lakes are formed, just by means of this very short video clip that we've got here.
In flat areas, rivers wander about, forming loops of all shapes and sizes on the valley floor. These are known as meanders. Although they all look different from above, they share the same common features.
As you can see, on the outside of the bend, where the water's moving faster, it's cutting into the landscape, forming that long cliff. But here, on the inside of the bend, where the water's moving much slower, all this stuff is being deposited.
The erosion has left a very small neck on the meander. If we strip the trees away and look at it from above, it's easy to see what will happen next. The fast-moving stream will continue to erode the banks on the outside of the bends. It also erodes the area around the meander's neck. Eventually, the river breaks through, cutting off the meander and forming an oxbow lake.
Wow, now isn't that a very nice explanation of how oxbow lakes are formed? Remember that? The 4 steps that we've shown you. Remember, the only thing I must remember is that the neck becomes more narrow and eventually the meander is cut off. But what's very important is that it can also be tested in your second question paper. I hope, Matric, you've seen how many times I've referred to the second question paper. This is very important. Okay, so here we've got the Berg River flowing here in this direction. Okay, and as you see here, we've got lots of meanders, and let's see what's happening here. What's happening is, the first thing that you must know, this is the direction in which the river is actually flowing. Now, see what's happening. I want you to see what's happening here. So what's happening is that you've got erosion here, and you've got erosion on that side. Remember, the river will be flowing faster there and slower on that side. Faster there and slower on that side. So what's going to happen? This means that this is going to become narrower and narrower. Right? The neck is going to get narrower, and eventually the river cuts through the neck. So let's have a look. We've got two different stages of the formation of oxbow lakes here. Here we got narrower, and here the river cuts through. Now, what's the next step? What's going to happen within the next 50, 100 years is that this bend is going to be completely cut off of the Berg River, and you are going to have your oxbow lake on that side. Okay, people are going to end off with stream piracy, which is a very popular question. Okay, now if you have a look at stream piracy, what is a pirate? Now, a pirate is not a very honest person, somebody who steals from other people. So, if we talk about stream piracy, then it means that this river is stealing something from another river. And the only thing that one river can steal from another river would be water, of course. So, let's have a look at this. Here we've got 2 rivers here, and what's very important that you must notice this river is flowing in that direction, and this is flowing in this direction. Immediately, what you must think about is, what is the only river that can steal the water? And please, people, I'm just using the word steal to explain to you. Okay, so let's have a look at this. So this river is, the most important thing that happens is this. Headward erosion. Have a look at this again. This river is eroding backwards. We call that headward erosion. Have you got that? Eventually, this happens. Let's have a look again. That's the river. Headward erosion eventually joins up with that river. And then, in the last process, that is happening. So this river here has completely intercepted the waters of this river, and this river is flowing that way now. So this is called stream piracy. Now, if we have a look at the features of stream piracy, is the following. The first one is the elbow of capture. Can you see it looks like an elbow? right? The elbow of capture is the exact place where the piracy has taken place. Secondly, the captor stream. Now the captor stream, now that was the guy who's the cheat. You know, he's the guy that's going to steal the water. Have a look at that. That's the captor stream. This one, headward erosion, and eventually he joined up with that one. So that one will be the captured stream because that one's water has been captured. This is the misfit stream, right? The misfit stream. The wind gap. The misfit stream is what being left of this stream, and this is the wind gap between your captured stream and this wind gap. You will find here lots of river gravel, and you can actually see, you would find where the old river actually was flowing there. That would be your wind gap. Okay, so if you have a look, if we've got two places, towns here, one here and one here, this one will be totally disadvantaged because its water has been cut off. There will be water shortages, farming, fishing, recreation, industries, all of them will have a problem, will be disadvantaged. Whereby this one, see what's happening, got more water, farming, nice economy, but the only problem is flooding because it's got more water, erosion. The water is going to, river is going to flow, much more water is going to flow much faster. Okay, so let's just have a look at this image here. Of stream piracy. This is what these two rivers look like at this very moment. But was it so all these years? No, this is what happened. This is what the rivers initially looked like. And immediately you must say, look at that photo, I know B is the only guy that can be the pirate. B is the one that will be the one that's going to steal the water from the other one. So let's see what happens. Exactly the same thing. There we've got our headward erosion, you see that? And that is what the river looks like now, and eventually we've got our features here. Here we've got the captor stream. Remember that one was the headward erosion. This is the captured stream. Here's my elbow of capture, right? Here's the misfit stream. And eventually, this area here is called the wind gap. Now, I'm just going to conclude with the question that was set in the February exams with regard to stream piracy. The first question here, they gave you these two. This was before piracy and this was after piracy. Label S and Y with the terms captor and captured stream. That's easy, right? That would be the captor one because that one is going to back up and eventually capture that one. Am I right? That's easy. Name the features at A and B. A, easy. That would be the elbow of capture. And B, you can see there in between, that would be the wind gap, the place that has been left dry. Right? Give two reasons for the river S eroding faster. Why would this river erode faster than that one? It's steeper and water has been added. And here we've got a paragraph which I will conclude with. This was the question. In a paragraph, explain the impact of river capture on the volume of water and the erosive ability of rivers B and S. They want to know, there's river B, there's river S. What happened? By B, there was less water after capture. There's a gradual slope, so there will be less erosion. By S, more water after capture, steep slope, and more erosion. Okay, people, so this concludes our geomorphology lesson for the day. I hope that when we come to your June exam or any exams that you're going to be right, that this lesson would help you to get the maximum amount of marks that you are worth for in your geomorphology. Till next time, bye-bye.